Hello everyone, it's a Grasshopper tutorial at the University of Queensland School of Architecture. Christina here. In this video we will consider a very important part of Grasshopper called domain. It's located at Math panel, domain. It doesn't hold any particular number or series of numbers. Domains actually deal with values within specified numerical range. Let's start with construct domain component. It has two input ports and one output. Input ports stand for start of your domain and the end of it. And we can specify it with a slider, with a panel, with anything you like. I prefer sliders because they're easier to manipulate and they are really kind of visible. You can see what you're doing. To see the result, you will need to have a panel here. This component just created a domain from 3 to 10, and all the values between 3 and 10 are held within this component. While working in Grasshopper, you will need not only specify or define certain domains, but also operate and manipulate these domains. So next component we'll consider is called divide domain. Here it is. Divide domain takes the whole base domain specified into this port and divides it into a certain number, certain amount of equal and independent ranges or segments. So we will take this domain we just constructed and divide it into 10 equal segments. Let's see how it works. So the domain from 3 to 10, is now divided into 10 equal parts that operate as independent domains, which you can use the way you like. If you do have certain numbers and you need to create a domain that holds these numbers, you will need this component called bounds. Let's put it here. It has one input and one output port. Let's call domain and specify some numbers. It has to be multi-line, by the way. This can be any numbers in any progression you like. Let's say 5, 46, 24, 55, and end up with unexpected 0. Connecting. Again, panel to see the result. And here we go. Bounds component took all these elements and created a domain from the smallest one to the largest one. All in between is in between. So from 0 to 55 is the new domain. Now let's have a look at deconstruct domain. It's opposite to construct domain. It receives base domain certain range and extracts starting point and the end point. Let's take what we just created, the new domain, and we'll need two panels to visualize the output results. So it took a domain and extracted its start, which is 0, and end, which is 55. Next component we will consider now is called includes. Here it is. It is used for analysis of numerical range. This component will check the introduced values and indicate if they belong to your range. So it has two input ports, value to test for inclusion and domain to test with. Well, we have our domain. Here it is. output from the bounds from 0 to 55. Let's use it. And we will need some numbers that we will test. We will take a multi-line panel and introduce two numbers. One will lie within our domain and one will be out of it. Let's take 135 as the number that is out of your domain, and let's say 35 as the number within domain. Connected here. Two output ports. One specifies if the number is within domain or not. Yes or no, true or false, Boolean. You can see it here if you hover over this port, or you can just plug a panel and see it. So first number is 135. It does not belong to domain from 0 to 55, so it's false. It is not within the domain, while 35 is within it, so it's true. Second port is called D, it stands for deviation. Deviation specifies the distance between this number and the end of your domain. So 135 minus 55 is 80, easy math. This is the difference between the last number in your last value, in your domain, and the number introduced. While 35 lies within the domain, hence no deviation here. The last component in this video is called Remapped numbers. It's a very important component, and it basically rescales the number with a certain range. We will create a range with I have to create it, I think we have it. Let's just have our bounds go in here. Where does it go? Here? Probably. Yeah, source domain. That's right. So source domain is the domain within which the numbers will be introduced. Values that will remap, we will have to introduce them using the sliders, or this time I prefer multi-line text. Let's say 10, 20, 50, no, actually 55, 43, so you can see it, 0, and 1000 at the end. Actually, let's make it the other way around, and let's create the new domain from here. We'll disconnect this, take bounds, pardon, not this one, bounds, create source, and these are the values we'll check. So now we created a domain that holds numbers from 0 to 1000. That's the domain. These are the numbers we are going to reparameterize on target. Target domain, let's make it something, let's make it actually 0 to 1. And connect it here. What happened? Basically, this component took these values and rescaled them. This is the initial domain, and this domain is the one that we are scaling. So now it's from 0 to 1. 1000 scale could be Nothing else. Why not? But it's easier to understand how it rescales your numbers using the same diapason. It's easy to compare your initial numbers to the outcome. These values reparameterized to these ones. That's all with domains so far. Thank you.